Hey, this is Miss S here. This is day 2 of chapter 2.4, multiplication of rational numbers. I'm going to scroll down in our book here to get to where we left off yesterday. And here we are. We left off at multiplication properties. So there are two properties that hold true. Just like in addition, we had the associative property and the commutative property. They are both the same as they were when we were adding numbers. So that associative property, remember, is you can move your parentheses, and it doesn't matter how you group A, B, and C. In this case, if you take the product of A times B and multiply that times C, it's the same thing as if you take A and multiply it times the product of B times C. The commutative property, that allows you to switch the order. So it doesn't matter which number or letter you put first. In this case, A times B is the same thing as B times A. Now with multiplication, there is the same sign multiplication rule. So let's take a closer look at that. So the same sign multiplication rule says, I don't want to do that. So it says the product of two positive or two negative numbers is positive. So let's say I have a -1 and I multiply it times another -1, my answer is going to be a +1. Or if I have a +1 and I multiply it times a +1, I'm still going to have a +1. So if you have two of the same signs, whether it be positive or negative, when you're multiplying, the answer is always going to be positive. Now in multiplication, there's the different sign multiplication rule. And what this one states is the product of a positive number and a negative number is a negative number. So in multiplication, whenever you multiply a positive and a negative number, your answer will always be negative. It's a little bit different than addition, because in addition, it depends on which number was bigger. It was a tug of war. But in multiplication, your answer will always be negative. So the one thing I hear a lot from you guys is you're always asking, when will I ever use this? You ask when will you ever use this? Well, let's take a look at a real world problem solving. So your friend Anne, she has a candy bar and she offers a piece to Bill. Bill quickly breaks off 1/4 of the bar and eats it. Another friend, Cindy, takes 1/3 of what was left, and Anne splits the remaining bar into 2 equal pieces, which she shares with the third friend, Dora. So how much of the candy bar does each person get? So before I start, I would just take my pencil and I would underline important stuff. So Bill, he had 1/4 of the bar, and Cindy, well, she takes 1/3 of what was left, and then Anne splits the remaining piece of the candy bar into 2 equal pieces, which she shares with a third friend, Dora. So she breaks that into 2 equal pieces. And so our question is, how much does each person get? All right, so now I've got my important information. So I'm going to start by thinking about this as one whole candy bar. So if I start up here with Bill, I take my one whole candy bar. He takes 1/4 of it right off the top. So I'm just going to subtract 1/4. And when I subtract 1 and I take away 1/4, I have 3/4 left. So after Bill took his piece, there's 3/4 of that candy bar left. Well, Cindy, she takes 1/3 of what was left. Well, we need to figure this out. What is 1/3 of 3/4? We can accomplish that by setting up a multiplication problem. And if we take 1/3, we multiply it by 3/4, we would multiply across 1 times 3 is 3, and 3 times 4 is 12. So 3 12s then can be reduced down to 1/4, and 1/4 is the fraction that Cindy receives. So Bill had 1/4, Cindy had 1/4, so now we just need to figure out what is left. So if I start with that original 3/4 that was left, and I subtract the 1/4 of a piece that Cindy took, I'm left with 2/4 because 3 minus 1 is 2, and my fourths will stay the same. Well, 2/4 can be reduced down to 1/2. So 1/2 is the amount that is remaining after Cindy took her piece. Well, it says here that Anne split that 1/2 into 2 equal pieces, which she shared with Dora. So it turned out that everybody got 1/4 of that candy bar. So let's look at one more example. So Doris's truck gets 10 2/3 miles per gallon. Her tank is empty, so she puts it in 5.5. She puts in 5.5 gallons of gas. How far can she travel? All right, let's start by underlining our important information. Doris, her truck gets 10 2/3 miles per gallon. She put in 5.5 gallons. So we want to know how far can she travel. All right, I've got my important information. So before I can start though, I need to start by writing each fixed number as an improper fraction. So I need to take 10 2/3 and convert it into an improper fraction. And I do that by taking my denominator, 3, and I multiply it times the whole number of 10. 3 times 10 is 30. And then I'm going to add those 2 remaining ones at top. So plus 2 is 32. So when you're converting an improper fraction or a mixed number into an improper fraction, you're going to multiply the bottom times the whole number and then add the numerator. So let's try that again here with our 5 1/2 gallons of gas. I'm going to take 2, I'm going to multiply it times 5. 2 times 5 is 10. Then I'm going to add my 1 on top, my numerator, and that gives me 11, so 11 halves. So now that I have both sets of numbers converted into improper fractions, I'm ready to multiply. So what I'm going to do to find out how far she can travel on that gas is I'm going to take the amount of mileage per gallon of gas that her car gets. I'm going to take that 32/3 and multiply it by 11 halves, and that's going to equal 352 over 6. Well, this can be reduced down, and it's going to take me a while to figure out how many 6s go in there. So I would start by doing some large estimations. Start with maybe 10. Well, 10 times 6 is only 60. Let's try 100. 10 times 100 is 600. Well, that's way too big. So then I would start kind of concentrating around the middle, maybe 50. Well, if I'm using my calculator and I have 50 and I multiply that by 6, 300, that tells me I am close. So then I would just have to figure, how many 6s maybe go into 52. Well, I know that 6 times 8 is 48. So I would guess 58, because 50 of them was 300, plus 8 more is 58. Well, 58 6s can go in there, and I have actually 4 remaining. So I'm going to convert this 352 back into a mixed number, and it comes out to 58 and 4 6. Well, this 4 6 can be broken down some more. I know that each of them is divisible by 2 because it's an even number. And after I do my math here, the 4 divided by 2 is 2, and 6 divided by 2 is 3. So 58 2/3 miles is how far she'll be able to travel on 5.5 gallons of gas. All right, so now we're ready to move on and get to our practice problems. There is a video here by Khan Academy. If you'd like to learn some more about multiplication of rational numbers, feel free to go ahead and click the play button and watch that video. But otherwise, we can go ahead and you are going to be working on problems 1, 5, 7, 9, problem 11, 15, and 17. And you're also going to be doing 19, 23, and 25. So I'm just going to point out that 19, 23, and 25, you are going to multiply the following by a -1. And remember, whenever you multiply a number or a variable by a -1, your answer is going to be negative. So if I look here at pi, grab my pen here, and I take pi, a -1, and I multiply it times pi, my answer is going to be a negative pi. So see how you do with 19, 23, and 25 and get your own conclusions. If you have any questions, please email me or get a hold of me. You can come into the Google Meets at any time. Otherwise, we'll talk to you later. Bye-bye.